Alright, so this video is 3.3, which is on increasing functions and the first derivative test. Now, people often get the first derivative test and the second derivative test confused. We're using the first derivative for this test for local, max, and min. Okay, or relative max and min. So that's basically what's happening here. Now, these things aren't super important. I think I printed all of this for you. So a function is increasing if for any two x's, here's an x and here's an x, two different x's, where this x is smaller, so this is the smaller x, this is the smaller y value. Okay, so it's increasing on an interval only if it's increasing the whole entire time for any two x's. In other words, this is not increasing even though it's went up. This is increasing because it goes up the whole time. And vice versa for decreasing. So it's just a technical definition. I wouldn't worry too much about it. The bigger y's are smaller than the little y's, basically, going down or going up. So here's how you're going to do this. If the derivative is positive for all of the x's in that interval, if the derivative is positive, that means the slope is either like this or like this or like this or like that, right? Well, what can you say about the function? It's going up, it's going up, it's going up, it's going up, right? So you see these functions and I drew in the tangent to it the best I could. So if the derivative is positive, that means the slope is positive. That means that the function is increasing. If the derivative is negative, then the function is decreasing. This is the derivative, and this is the regular function, remember. And if the derivative is 0, then it's constant on the interval, or it could be a max or a min, but it's flat. So a function is strictly monotonic if it is either increasing or decreasing on the interval. So that means it's kind of like increasing on the whole interval. It's always increasing. This is not a really important thing to worry about. It's just there. So I think this is actually the wrong page. But in your book, if you look in 3.3, you can find like a little synopsis of how to find intervals where things are increasing and decreasing. But let's just get right into it, okay? Find the intervals which this function is increasing or decreasing. So what you're going to want to do is find the derivative, and then you're going to want to set that to 0, f prime equal to 0, and then you're going to want to make a number line. Now that's an interesting thing, and we'll cross that bridge when we get to it. So the first thing that's pretty easy is to find 3x squared minus 3x, and we want to set that equal to 0. We want to find this for a reason, because we know that when the derivative is 0, well, then the derivative is not positive or negative. It can't be. So we know that these are our critical points, our candidates. Remember we did this earlier. These are critical points. It's a positive one. Critical numbers or critical numbers because they're not points, right? So here are our critical numbers. Now, what we're going to do is we're going to make a number line. It's pretty simple. We're going to make a number line and we're going to label it f prime. So we're looking at what happens with the derivative on this number line. We're going to put two values on it. We're going to put the 0 on it. We're going to put the 1 on it. These are these guys, okay? So you'll notice that those numbers come over here. Now we know that derivative is 0 here and the derivative is 0 here, so I'm going to go ahead and put that. But I want a number in between 0 and 1. Let's say 1/2. Okay? Well, if I take 1/2 and I put it into the derivative, which is here, I get 3 times 1/2 squared is a 4th. I'm putting this in the derivative. I'm putting this into this function over here, okay? Minus 3 over 2. So I got 3/4 minus 6/4, I think. 3/4 minus 6/4, I get a negative number. This comes out as a negative. So in other words, this negative is saying that the derivative is negative this whole time. It was never 0, so it must have been either negative or positive. It never crossed 0 until 1 or 0 until these numbers. So the derivative was negative this whole time, so we have decreasing there. Now what we need to do is take a number that's over here. So any number will do, but let's just take 2, and let's take negative 1. So I'm going to go ahead and test these numbers. So let me just get a different color maybe. So negative 1, I pulled that number out of my head. I'm going to plug it into here. I've got 3 plus 3. So I've got a positive, and I realize that that means that the derivative is positive this whole time. When I plug in 2, I get 12 minus 6, which is a positive 6. So I'm going to put a positive here. Now, you have to explain this number line, or at least understand it. So we have that the function's going up, then it's 0, see it's flat. Now the function's going down, then it's 0, it's flat, and then the function's going up. So that's what this function kind of looks like. Here's that 0, right? That's this. And here's that 0. That's this. And we know that we have a max when the derivative goes from positive to negative. So our max is when x is equal to 0 for this example. That's a relative max going up and then going down, plus to minus. Okay? Positive derivative, then negative derivative. And if it changes from negative to positive, that's a local min. So we have a local min when x is equal to 1. And of course, we have to have an actual function that's defined there, right? We have to have the derivative. I guess you need that f of c exists, right? You can't say that an asymptote is a local max or a local min just because that satisfies those points. So that's basically what we're talking about. So it's pretty straightforward. We know that the function is going to be increasing every time that it's positive. So I'm going to say that this function is increasing from negative infinity. It's always increasing until 0. Union, when does it start increasing again? Well, it's not increasing in here. It's increasing at 1. And then forever it's increasing. So this is where the function's increasing. And where is the function decreasing? Well, the function's decreasing from 0 to 1. So this is our interval of increasing and decreasing. And our local max and min happen when x is 0 and when x is 1. That's not our actual answer. So really just gave you 1 point. Try to find where it's increasing and decreasing. And also, could you find the local max and min? Because I took it pretty easy on you today. So local max and min, if there are any. And find the y values too for those if you could. Okay? So pause the video, give that a shot, and that's pretty much it, I think. So keeping it short and sweet, give this a try, and I'll see you soon.